All right, welcome to section 2.5 part 2, where we're going to be graphing how to graph rational functions. This is very similar to when we did graphing a polynomial functions, very similar. All right, so this first page should look familiar. This is what we talked about in the last section. A rational function is when you have a quotient of two polynomials, so a of x divided by b of x. Remember, b of x cannot equal 0 or else it would be undefined. The domain of a rational function is always all real numbers except those numbers that make the bottom 0. Okay, so it's always going to be all real numbers except whatever makes the bottom equal to 0. All right. Now, then the second page is a really important chart. And basically what this chart does is it helps us determine what our horizontal and our vertical asymptotes are. Okay, and then so the important part is that the exponent of the numerator is n, and the exponent of the denominator is m. Okay, and that will help us determine. So if your n is less than your m, the horizontal asymptote is this. If n is equal to m, then it's, there's different things here. And we'll talk about more like that. And then the vertical asymptotes may occur, so wherever the real zeros are b of x. So we'll work through an example and we'll make sure that this makes sense. All right. So it says steps to graphing rational functions. To graph a rational function, first simplify f of x if possible, and then follow the following steps. Step 1, find the domain. Step 2, find and sketch the asymptotes. Step 3, find and plot all x and y intercepts. And step 4, find and plot one point in the test intervals, which are determined by the x-intercepts and vertical asymptotes. So we'll get to all that. This will make sense when we do an example. Okay, so example 1. It says f of x equals 6 over x plus 3. So step 1 is to find the domain. Okay, so like we talked earlier, the domain is all real numbers except for whatever makes the bottom equal to 0. So what makes this bottom equal to 0? What plus 3 is 0? Well, x cannot equal -3. Okay, so the domain is everything but -3. Okay, step 2. We are going to find the horizontal and vertical asymptotes. The vertical asymptotes are always the easiest. The vertical asymptotes are what makes the bottom 0 again. So our vertical asymptotes, what makes the bottom 0? -3. Okay, so our vertical asymptotes at -3. Now our horizontal asymptotes, we're going to need to use the chart. Okay, so the chart says, let's go back to that. The horizontal asymptotes, we have to look at the exponents of our numerator and denominator. So what is the highest exponent of our numerator? Well, this is really like x to the 0 because there's no x there. So our n is 0 and our numerator on the bottom is 1. So 0 is less than 1. So our n is less than our m. The top is n, the bottom is m. So what we have to see, when our n is less than m, what does it say about our horizontal asymptotes? If n is less than m, okay, our horizontal asymptote is at y equals 0 every single time. All right, so our horizontal asymptote is y equals 0. All right, so let's do step 3 now. Step 3 is to find our x-intercepts. Okay, what are our x-intercepts? All right, so our x-intercepts are what makes the top part 0. Okay, to find the x-intercepts, it's what makes the top part equal to 0. Well, it's just 6. There's no variables. So there's nothing on the top that could possibly make this 0 because it says equals to 6. So there are none. So this one has none. This will never cross the x-axis. Okay, and the y-intercepts, okay, it's very simple. You plug in 0 for x and you see what you get for y. So you do f of 0. So 6 divided by 0 plus 3. This is 6 over 3, which is equal to 2. Okay, so our y-intercept is equal to 2. Okay. And that is basically, for right now, all we're going to need to use to graph. All right, so let's graph what we have so far. All right, we don't need to graph anything on our domain. Our vertical asymptote is at x equals to -3. So I'm going to go 3 to the left, and I'm going to draw this dotted imaginary line to x equals -3 because that's our graph cannot touch at that spot. Okay. I'm also going to graph my horizontal asymptote, which is at y equals to 0. Well, that's the x-axis. So I'm going to draw this dotted line right through. Okay, so my graph can't touch there as well. All right. Now we're going to plot our x-intercepts. Well, we don't have any, so there's nowhere on the x-axis that I need to plot. Now I'm going to plot my y-intercept. We have a y-intercept of 2, so I'm going to go up 2. This is where this graph will cross the y-axis. Okay, now what we need to do is we need to test some points. And the test zones are between the x-intercepts and the vertical asymptotes. Well, we don't have any x-intercepts, so we don't need to worry about those. But we do have a vertical asymptote, so we need to test some points to the left and to the right of this vertical asymptote. Okay, so we're going to use the right-hand side here to do that. All right, so let's see here. Let's first, okay, give me a number to the left of my vertical asymptote. So if my vertical asymptote's at -3, let's test -4. So I'm going to plug in -4. So 6 over -4 plus 3. That's equal to 6 over -1, which equals -6. Okay, so at -4, my graph is equal to -6. 1, 2, 3, 4, 5, 6. All right, now let's test -5. Okay, actually, let's do, I think -6 will work better because we won't get a decimal. So let's try -6. Oops, actually, -6. 6 over -6 plus 3, that's 6 over -3, that's -2. So -6 is going to give me -2. Okay, now let's try -7 will give me an odd number, so or decimal. So let's try -8. Let's test -8. 6 over -8 plus 3, that is 6 over -5. Actually, this is a decimal 2. You actually get -1.2. So at -8, you get -1.2. Okay, so you can kind of see we have this shape here. And notice I'm not going to touch my asymptotes. We're going to get really, really close, but we're not going to touch. So that's to the left side of my vertical asymptote. Now we got to test to the right. We already have 1 point. Let's plug in a couple of other numbers. Let's do -1. So f of -1. So 6 over -1 plus 3, that's 6 over 2, which is equal to 3. So -1 is equal to 3. 1, 2, 3. Let's see what else we should try. Let's try 1. What do we get when we plug in 1? F of 1. That's 6 over 1 plus 3. That's 6 over 4, which is 1.5. So when we plug in 1, we get 1.5. Okay, so we can kind of get an idea here. Now you could do more. Okay, we could do a few more, but we kind of get this general idea of what's going to happen here. And we can't cross our asymptotes, and we can't cross our asymptote on here on the left either. Okay, so there's our rational function. It's always discontinuous at the vertical asymptotes and at the horizontal asymptotes. Okay, that's example number 1. All right, here's example 2. Same kind of thing, it's just a different example. All right, so remember, step 1 is to find the domain. Okay, the domain of this one is, remember, it's all reals except for the number that makes the bottom equal to 0. So x cannot be equal to what number? 3 minus 3 would be 0, so x cannot equal 3. Okay, so let's not forget to simplify the function first. All right, so let's factor this, so this will help us later. So x minus 3 is factored. What two numbers? Okay, so what two numbers multiply to be 10, but add to -7? Okay, hopefully you see that that's -2 and -5. Okay, so now this is fully factored. Nothing cancels. This is just what we have left over. All right, so step 2 is to find the vertical asymptote and the horizontal asymptotes. Remember, the vertical asymptote is whatever makes the bottom 0. So our vertical asymptote is x equals 2. We just figured out 3. Okay. Our horizontal asymptote, we got to use that chart from previously in the notes. So let's remember that we have to look at the exponents of our original problem. Okay, our top exponent is 2, and our bottom exponent is 1. 2 is greater than 1, so n is greater than m. So if we go back to our chart and look at this, what does it say when n is greater than m? It says that there's no horizontal asymptote. Okay, perfect. That's less work for us. So there is none for horizontal asymptotes. Okay. The next step, step 3, is to find the x-intercepts. Okay, and the x-intercepts are what make the numerator 0. So what makes x minus 2 0? Hopefully you see that that's x equals to 2. And what makes the right one 5 minus 5, so x equals to 5. So we have two x-intercepts, one's at 2, one's at 5. And last but not least, we need to find the y-intercept, and to do that, we plug in 0 for x. Okay, so f of 0. So 0 minus 2 times 0 minus 5 all over 0 minus 3. So f of 0 is equal to negative 2 times negative 5 all over negative 3. So that's 10 over negative 3. 10 over negative 3 is equal to negative 3.33. Okay, so it's okay. It's a decimal, which is okay. All right, so we have our domain, vertical asymptote, horizontal asymptote, x-intercepts, and y-intercepts. Okay, and then our next step is to plot all of that information. All right, so let's plot this. All right, so we have our domain. We have our vertical asymptotes at 3. So I'm going to go to 3. I'm going to draw in my vertical asymptote. There is no horizontal asymptote, so I don't need to draw that in. We have x-intercepts. Our x-intercepts are located at 2 and 5. Okay, here's 2, 3, 4, 5. Okay, now we have some zones here. We need to plug in numbers to the left of our x-intercept, in between our x-intercept and our vertical asymptote, in between our vertical asymptote and our next x-intercept, and then to the right of our x-intercept, so we can get some ideas of what this graph is going to look like. We can also plot our y-intercept, which is negative 3.33. So 1, 2, 3, probably about right there. All right, so let's figure this out here. All right, so let's give me a number. Let's plug in 1, okay, to the left of our first x-intercept. So let's plug in 1. So we're going to plug this into the original function. Let's plug it into our original, because that's the easiest one. So let's plug in 1, f of 1. So 1 squared minus 7 times 1 plus 10 all over 1 minus 3. So that's 1 minus 7 plus 10 all over negative 2. So 1 minus 7 is negative 6. Negative 6 plus 10 is 4 over negative 2. So negative 2. 4 divided by 2. So 1 is equal to negative 2. All right, now let's plug in a number between 2 and 3. So let's plug in 2.5. So 2.5 squared minus 7 times 2.5 plus 10 all over 2.5 minus 3. Let's use our calculator to help us with this. So let's do the top. So 2.5 squared. And then this is minus 7 times 2.5. Negative 11.25 plus 10 is equal to negative 1.25. And that's all divided by 2.5 take away 3 is negative 0.5. So that's equal to 2.5. So this, all of this right here is equal to 2.5. So when I plug in 2.5, I get 2.5. Okay, so we can see the general shape of this now. Remember, I can't touch the asymptotes. Okay, there's the left side. Okay, now let's plug in a number between 3 and 5. Let's plug in 4. I'll do 4 over here. All right, so 4 squared minus 7 times 4 plus 10 all over 4 minus 3. That's just 1. So that's 16 minus 28 plus 10 all over 1. So let's see here. So 16 minus 28 plus 10. And what do I get? I get negative 2. Okay, so between, let's see here, 3, so 4, I get negative 2. All right, and now let's give me a number to the right of this last interceptor. So let's plug in 6. Okay, so let me get rid of some of this. Let me get rid of this. Let's plug in 6 and see what we get. So f of 6. So I get 6 squared minus 7 times 6 plus 10 all over 6 minus 3, that's 3. So 36 minus 42 plus 10 all divided by 3. So let's see what we get here. So 36 minus 42 plus 10 all divided by 3, and I get 1.333. Okay, so this is equal to 1.33. So when I plug in 6, I get 1.33. And now we have the general shape again. Oops, I missed my point. Okay, and there is our shape. All right, so that is example 2. I have 2 more examples on the homework. Example 3. This talks about when the exponents are the same on the top and bottom. We do something a little different there. And then the last one is when, after we factor it all out, we have things that cancel on the top and the bottom. So we'll do both of those in class to make sure everybody's on the same page. Have a good night, and I'll see you tomorrow.